This fan's not crack-a-lackin'. It's crack-a-lottin'. Huh? What's that? Bad puns are only for the end of the video. Well, fine. Roll into the credits, I guess. After 20 long years and almost 200,000 miles, Dora's OEM mechanical radiator fan has had a rough life. It's time to retire this fan and replace it with a brand spanking new Mustang electric radiator fan. It will be set up to turn off and on at certain temperatures, as well as turn on when the air conditioning is activated. To make all this work, there are a few extra parts needed, such as an additional coolant temp sensor, an inline adapter for the sensor, and a couple relays. All of these parts can be sourced from Amazon. Let's get to it. Start by removing the throttle body cover and the air filter assembly. Next will be to remove the fan from the water pump pulley. A special tool makes this a breeze. Once the fan is loose, the two 10mm bolts for the fan shroud are removed. The fan and the shroud will come out together. Now we can move on to the fun part, installing the new parts. I opted to go with an electric fan assembly for an 05 to 09 Ford Mustang. Turning the assembly 90 degrees onto its side allows it to slip into the gap of the radiator. There was a slight clearance issue with the old fan mounting stud, but that was solved by trimming the outside edge of the new assembly by 1/4 inch. Time for the messy part. The coolant needs to be drained before mounting the new coolant sensor. I chose to mount the sensor housing into the lower radiator hose, between the block heater and the engine block inlet. This ensures the fan will only activate when the radiator can no longer dissipate the heat on its own, and will prevent the fan from needlessly running while Dora is in motion. Because of the tight clearance of this hose, a section of the hose equal to the exposed part of the sensor housing will need to be removed. A box cutter or garden shears work nicely. Just for fun, let's peek inside the coolant hose. This brown gunk here is what happens when the coolant becomes contaminated and breaks down. Too much buildup of this stuff can reduce the effectiveness of the coolant. Periodic coolant flushes will greatly reduce the chance of this happening. The sensor housing is held in place with two hose clamps. I made sure to orient the housing to make the sensor more accessible when installed. Tighten the sensor to snug. Thread sealant is not recommended. This sensor is designed as a switch to ground out through the housing. Any sealant or Teflon tape could cause the switch to not function at all. There will be two wires running to this housing, one for the sensor and one for the ground. Work the hose back into place and refill the cooling system to check for any leaks. With all the parts installed, all that is left to do is the wiring. Here's the wiring diagram I created. This fan has two speeds. Each speed is activated a different way. When the coolant sensor reaches 190 degrees Fahrenheit, the switch closes, grounding out the control coil in the low-speed relay. This in turn allows power to flow from the battery to the low-speed wire on the fan. When the sensor reaches 175 degrees, the switch opens, turning the fan off. The power side of the control coil comes from a switched ignition source to prevent the fan from running when the key is not on. The high-speed relay control coil gets its power when the AC clutch is activated. This causes the high-speed relay to disconnect power from the low-speed relay and send it directly to the high-speed wire on the fan. When the clutch is deactivated, the relay returns power back to the low-speed relay. In the future, I will tidy up this wiring better, possibly with some cable sheathing. The ignition source I tapped into is for the ABS system. Any fuse that is only hot when the key is on will also work. The splice into the AC clutch will fit nicely into the OEM cable sheathing. Because the new sensor is mounted after the radiator, the ECM coolant temp reaches 208 to 210 degrees before the fan activates. This is within normal operating temperature range, and the temperature drops quickly once the fan is activated. Lastly, we can see when the AC clutch is activated, the fan starts right up, almost like magic. This is Rooster. If you waited all this time for a bad pun, it's gone. Blown away.